Okay, welcome back 2220 students. I'm going to continue on the program taking a decimal number, converting it into a binary number. What you see on my screen is the way all of your programs should look. Comment, header, date, purpose, name, the preprocessor directives, the prototype for your functions, beginning of main, ending in main, comment, all your functions written below main. I do like a comment there, or the comment there, so I know it's the end of main, and other comments throughout your program. All right, so the binary number program, let's talk about it. First thing I'm going to need is a place to store the binary number, or the decimal number. And I like to default everything to 0. I'm going to need a place to store the binary number, and that's going to have to be inside of an array. And my array is going to have size elements. And when I create an array, I like to use the constant size, and then I define it. Let's just call it 1,000. It doesn't really matter. Anytime I have an array, I need effective size in the array. So my effective size, I like it to call it E size. And this effective size, every time I add one to the array, I increment. Every time I take something away from the array, I decrement. So there I go so far. All right, so here's where I'm going to get the input. And I can get way more complicated than that, and we will later in this semester. I'm going to scan in an integer if I can only type. So I'm going to scan an integer into this decimal number. So now I have the value, and the next thing I'm going to do is, because I have to keep dividing and I want to keep the original number, I'm going to have a temporary value. Let's just call it temp. And after I read the number, I'm going to use temp to do all the dividing. So temp's going to equal that decimal number. So my process is really simple. I keep dividing and storing until, so here's the entire process. It's just a little do-while loop where I keep doing modulus division, storing the remainder in this array at the eSite location, and then keep chopping the number into using integer division, which removes the remainder and truncates. So that will populate the array, and when I'm done with this little loop, this array will have the binary number equivalent of this decimal number in reverse order. So the next thing I'm going to do is the output. So I'm going to do this output in two parts, one sentence. I'm going to say the decimal number, 5, converted to binary, and then I'll say the binary number. So hopefully you're familiar with printf and the placeholder for an integer. And notice I did not do a new line because I want the binary number to appear on the same line. So here's how I print out the binary number. I start at the far right location, which would be esize minus 1, because esize points to the next location. Esize minus 1 is the last populated location. And I work my way down to 0, and I just print without a new line across the board. When I'm done with that, I probably do want to do a new line, or even 2. And then I believe what I want to do is pause so the screen can be read. So to pause, I would want a system pause, but because I'm lazy, I like an alias for my pause. So what I do is I come up here, and I create an alias. This word pause and this system pause with all those are equivalent. This is an alias for this. Anywhere I use this, this is what I'm really typing. And in all reality, I normally bring in my CLS at the same time. And that's for clearing screen. So far, so good. I think I can run this. Let's see what happens when I run it. Oops, got an error. This had 2 errors. I left that semicolon off, and I forgot to put the int in front of the I. So once I do that, it should run. And it does. So here's my output. I enter a decimal number, 4, and if you check it, this is the binary equivalent of 4. And if I want to run it again, I can. And this 666 converted to a binary number is this guy right here. And you really need to get a calculator or go out to the internet, and you need to verify that that is correct. Do not take the program's word on it, and test this several times until you feel comfortable. I'm going to hit press any key to continue, and the program ends. Basically what I want to do is, instead of at the program end, I want it to say, would you like to do this again? So what I want to do at the end of this code that works fine is say, would you like to convert another number? And maybe prompt the user maybe something like y/n, so they know I want them to type the letter y or n, and then scan it into a variable that I haven't created yet. I'll just call it again. And then if that's the case, I want to take all of this and stick it inside of a loop, or a do-while loop in this particular case. So this is going to be my do-while loop. Take the perfectly good code that's worked, and I'm going to loop again. Well, again equals a capital Y. If again does not equal capital Y, I'm going to exit out of the program. So I need to get my indentation correctly. So I highlight, tab. And then the only other thing I need to do is the next time I come in here, and each time I do another number, I need to reset the E size. It's okay I did it up here when I did it once, but if I'm doing it multiple times, I need to reset the E size. And then the last thing I'm going to do is, in case I do this multiple times, I'm going to clear the screen. Let's see it run. Oops, I forgot to declare again. Should work now. Let's try it. If I can only type, it'll work. Should work now. Let's try it. So the program runs. I enter some number. It comes and tells me the number converted is that. There's the pause. And here's the prompt, would you like to convert another number? But notice it doesn't stop, and that's because of that flush problem. If you haven't seen my video on flush, you need to watch it. It's on the social. So to solve the flush problem, I create a new alias called flush. This is the command that will go through the keyboard, consuming all the values until it hits the enter key. Oops. And once it does, the keyboard buffer will be cleared. Will be cleaned, and I would execute a flush after every scan. Because they kind of go together, I like to put it right on the same line like that. So anytime I scan, I should clear the keyboard buffer, unless I really didn't want to, and I don't see any programs in this class where you're not going to want to. And now it's going to stop. As a matter of fact, since it's going to stop, I'm going to remove that pause and watch it run now. So I enter a number. And you let me put double quotes here. You should have been yelling at me because I'm comparing a character that is single quotes. Now this will work. So I enter a number. There's the binary. And now this time it stops and says, would you like to convert another number? I say yes, and it lets me enter. Oh, no, it doesn't let me enter another number. Actually, I expected it not to because this is a lowercase y and I'm testing for an uppercase y. So let's fix that. That's an easy fix. I'm going to come here, for example, and say, again, gets to upper again, and what I'm going to do here is I'm going to convert it to all caps for the test here, so I know for sure I have an uppercase letter. That happens to be in the C-type header file. If you didn't know it, you'd, and your IDE that you're using it would yell at you. And you'd figure this part out. Let's run it again. There's the number. I would test that. Do I want to do it again? Little y, click screen cleared, and I could do this again. Little y, screen cleared. I could do it again. Anything but a y is the same as n, and the program ends. So there's my program. That's in 10 minutes. So I'm going to stop and I'm going to do this one more time. But this time, I'm going to take all of this code and break it into functions. So I'm going to have a part 2 of this.